said it's just me? What happened to Jess? I don't know how hydration works. I can't explain this. Is she still in the room of reflection or whatever that is? What's going on here?
I made it out. Kind of like a mirror maze in there.
Oh, a mirror maze. Okay.
Yeah, all that reflection.
Okay,
yeah.
You're not like traumatized after all this? Or?
No, I feel like I feel like I was kind of told before I went in that if I was able to make it out of the mirror maze, I was considered forgiven. So.
Oh, okay. Okay, good. So there's no restrictions on jokes in our time.
I don't think they want me to, but I'm going to do it anyway.
Okay, all right. Sounds good.
I guess we should probably get started.
Yeah, let's jump in.
All right, hi everybody. I'm Jessica from the Angular Framework team.
And I'm Doug from the Angular tooling team.
And this is What's Cooking with SSR. So in version 17, we made it super easy to add server-side rendering to a brand new application using ng-new-SSR. And this is pretty awesome. It makes it super easy for you. It also supports pre-rendering and static site generation right out of the box, and you can play with it right away with ng-serve.
But then I already have a number of Angular applications already. I don't want to delete those and like recreate them from scratch. That sounds really frustrating. Is there some way I can adopt SSR for those?
Well, Doug,
it's right there.
Yeah, you should probably know about it too, because your team is the one that actually implemented that.
Sorry, so, that's on me. I should have known that.
Yeah, so you can, with an existing app, you can just use ng-add at Angular/SSR, and it'll set it up for you in your existing app right out of the box. It's awesome. So,
I think you skipped a slide.
Did I skip a slide? I think I did. No,
there's...
Oh, it's skipping right over a slide for us. That's
I am
wonderful.
not pressing a button.
Yeah, it's skipping over a slide.
Let me try.
Nope. Well, we'll just say the slide anyway. So, if you want to enable hydration, the really cool thing is we actually stabilized that last year. Full app hydration now is now by default when you use that --SSR. So you don't even have to enable it. If you are wanting to add it to your existing app, you may have to add that line manually, but the nice thing is that it's still only one line.
Yeah, so hopefully we'll fix the slides after that. But beyond that, your Angular material components now also support server-side rendering out of the box. So you get the full suite of Angular material. They look fantastic. They're really accessible. You get all these great features. They server-side render great, take full advantage of hydration and performance. So we highly recommend that. Now, the keynote spoiled this a little bit, but I want to show how we're updating Angular dev tools to make debugging and inspecting hydration easier for you. So I'd like to dive into up here where I'm inspecting angular.dev, which is a very cool site you all should check out. And in the bottom right corner, we've got show hydration overlays. And this brings up this little red bar on the side that shows me that this side panel is not hydrating correctly. It's got this nasty little span at it. And on the components panel, it even shows exactly what the problem is and what I need to fix. Now, I don't know about you, but this is right before lunch. I'm really hungry. I don't want to deal with this. So let's just put ng-skip hydration on that component. Really top-notch software engineering right here. And what we got here is if we relook at it, we see, oh, this side panel is now being skipped. There's no error. Everything works just fine. Now, we are taking a slight performance penalty for this. It's actually re-rendering this side panel from scratch on page load. But everything else is still hydrating. We're still getting great performance all around. And most importantly, I can merge this, ship it to prod, and then go get lunch and come back on a full stomach and actually debug the problem and squeeze that last little bit out of hydration.
I'm so sorry you're so hungry. I had some Angular cereal earlier to tide me over.
That would have been good. But Angular doesn't stop there. We've drastically improved our build tooling for server-side rendering with the new application builder. This is much easier to use with a significantly reduced configuration. And Angular Universal is no longer necessary. We just support SSR, SSG right out of the box. No additional integrations, projects, nothing you need to worry about. It just works. Not to mention, we've also got Vite and ESBuild included in here, so you get faster builds all around, even for your client-side rendered apps. But also, we've got additional improvements for server-side rendering and static site generation. So you get up to 80% faster builds for your SSR apps, which is huge. Yes. very excited about that as well. So the main takeaway here is that you no longer have to choose between a good development experience and server-side rendering. You can have both. And it's so easy to adopt SSR. I mean, why wouldn't you do it?
I don't know, Doug. Frankly, I don't want to maintain a production development server. I don't want to wake up at 2 in the morning because some jerk on the team forgot to renew that SSL certificate.
Is that a recurring problem, or?
Yeah, I'm a front-end developer. I don't know anything about the meanings of like uptime and reliability or like multi-threading. I'm not convinced any of these concepts actually exist.
Okay, well, as a front-end developer, I can confirm multi-threading is a myth. But beyond that, Angular does have 2 easy solutions to allow you to avoid having to manage your own server here. First, you can kind of go serverless. You can configure Application Builder to pre-render all of your routes at build time, but disable server-side rendering. This way, you actually don't have any server to run. When you ng-build, there's no server there. And you can instead upload these files to the same static file server you're already using for your existing client-side rendered application. This is all pre-rendered. It supports all the hydration stuff that we're talking about. And it can give you better performance because you can host this directly on a CDN, even closer to your users. And you don't have to wait for rendering at request time. So if you're thinking about adopting server-side rendering to your existing client-side app and don't want to worry about a server just yet, this is a really great way to get started. But pre-rendering doesn't solve all your problems. Sometimes you do need real server-side rendering. And for that, we have really, really solid integrations with a lot of cloud providers to make it super easy to deploy your server application to a number of different platforms. We work closely with them to make sure you have a really smooth experience and you can get their great performance and reliability without a complicated setup process.
So next up, we have these buns in the oven. This is the stuff that's in the works. Doug, did you know that if you actually add too much water to bread dough, it's actually going to ruin the bread while you're trying to bake it? It doesn't turn out very good.
Is that what's happening over here? Because I don't think my oven wants me to do this.
I think that's a slightly different problem, but the great news is that the solution to fix this problem is to only partially hydrate it.
But how do we do that?
Well, that's a good question, Doug. So yesterday during the keynote, you guys saw a really cool video demo of the partial hydration solution that we're currently working on. And you may have heard this phrase yesterday, that deferrable views are the foundation for partial hydration. I think maybe like Minko may have said this, or Jeremy, or...
Did anybody say it?
I don't think anybody did. Not even me.
You're saying it now. Are you just quoting yourself right now?
I think that's probably what's happening. I'm quoting myself right now. So deferrable views are the foundation for partial hydration. So what does that mean exactly? Let's take a look at this quick example. We've got a regular old defer block in our code with an on-interaction trigger. We've got a component in there for Angular serial. We've got our placeholder that we're going to render out. And if you're using full application hydration as it is right now with server-side rendering, what's going to get rendered on the server is that placeholder content. And it's essentially going to get fully, eagerly hydrated at the same time as the rest of the app. The difference with partial hydration is we're actually going to render through to the main template of that defer block on the server instead. So rather than having that placeholder content, in the same example, we're actually going to get the main deferred template loaded. And the really awesome thing is when this hits the client side, those dependencies are still deferred. So it's still not included in the main bundle. And so essentially what happens here is that main template becomes your new placeholder. This introduces some slight differences in the way that these triggers behave, because the previous version with full app SSR as it is right now, the triggers essentially handle fetching dependencies, and they also handle the rendering process. But now they still do the fetching of dependencies, but instead they actually trigger hydration.
So it was already pre-rendered, so once we fetch the content, we don't need to re-render it again. It's already there. We just hydrate what we already got.
That's exactly it, yes. This is also skipping over one of our slides. What the heck? We'll see if it... There we go.
Okay,
For some reason, this is skipping over slides. So let's take a look at this example here. We're looking at adding a bit to the defer block AST so you can specify how you want these to render through on the server. So we're looking at a render keyword followed by where you want it to render. So in this case, server with some parentheses that maybe you'll be able to add some parameters into. We're also looking at adding a global configuration, so you can specify for your whole application that you want all of your defer blocks to render this way on the server. That way you don't have to go like piecemeal every single defer block. You can just say every one of them render through on the server. And then you'll have the option of overriding it. So if you have one defer block that say you don't want to render through that way, you can say like render client and it'll be fine. It'll render the way it currently does right now. So there's some nuances that come with this that you need to be aware of also. So normally, defer blocks fire top to bottom, and this is necessary because with the use of defer blocks right now, naturally, if you have nested blocks, the nested content won't actually be there yet. So you have to have that parent element triggered before you'll actually see the next one, which would then trigger and then see the next one. That's the top to bottom behavior. Here's an example of what that would look like. If we have a defer block wrapped around our serial component, you then have to trigger that before it's rendered. Then it triggers the marshmallow component. And finally, all of the child blocks are present. This is reversed in a partial hydration world. So here's our example of the bottom-up behavior. The difference here is that in this orange section, all of this is actually now your placeholder. You can actually see that buy button already and start to interact with it. So in this situation, if someone tries to interact with that button, what's actually going to happen is the event itself of the interaction will travel all the way up to the highest defer block parent, and then trigger that defer block, and then cascade back down to the element that you clicked on, hydrating along the way.
So since this button's already there, right, we don't need to render just to get it there. We can already click on it, walk up that tree, and then hydrate back down.
That's exactly right. So I promised that we'd get to look at the demo, so let's do that.
Yeah. I'm very excited for a live demo.
Yeah, now I got to figure out how to get to it. There we go. Is this showing?
I think that's on the wrong display.
It's on the wrong display. Let's see. Can we? Oh. There we go. We're starting to move it over, and there we are. All right.
No, hang on. I wanted a live demo. This is a mock-up. What are you showing me?
I know. We kind of really kind of overdid it with the like. This is a kind of looking like a mock-up thing, but
yeah, I think you took the UX mocks a little too literally here.
I know, but I guarantee you this is an actual application. We can actually inspect it and look at the actual
Okay, I'll trust you.
So slightly different from yesterday's demo. We've actually added this little block at the top. I hope everybody can read it, but maybe we'll make it even one more bigger, where you can see exactly how many components have loaded and how many have hydrated. We've got this currently in a frozen state before hydration has ever occurred. Just like yesterday, the same colors apply. So gray means that this is dehydrated content. Blue means a section has hydrated. And orange means that a section is in the process of fetching before hydration. So let me unfreeze this by removing this super fancy URL parameter. We'll hit enter here, and again, we've artificially delayed this. So there's a few seconds before this actually kicks in. So
let her cook. It takes time.
So we've got now we've got our header, we've got our shopping cart, our navigation, and our footer are all hydrated as part of the eager hydration step at the beginning of the application's load, and we've still got this dehydrated content that now we can interact with.
Yeah, so I could use a new pair of headphones. It was like I could use like 2D paper headphones, like what we got there. You know, I feel like that fits really well over the years.
You really want? Oh, I mean, okay, Doug. All right. Well,
yeah.
Let's add to cart, and you can see it immediately starts to fetch, and that cascading behavior of cascading down from the top happens, and now we actually have an interactive app, and you can see there's one item actually in the cart. Up on the upper left, you'll see 6 components, both loaded and hydrated.
Yeah, I could also use a hat. It seems like that didn't hydrate yet, but I could really use a hat right now.
I mean, okay. You could probably like wear the two at the same
go over
time?
over the headphone.
Okay.
You know, it's 2D headphones. It'll fit fine.
Okay, all right. Well, let's do that. Now we've got that adding to cart. You can see up in the upper left, we got 7 and 7. And now there's 2 items in the cart. And just for funsies, we'll give you some shoes too.
Yeah, sure, why not?
All right, so we'll click add to cart there, and you'll notice that once it finishes loading, up in the upper left, we've got 7 items, but actually 7 components were loaded, and 8 were hydrated because it's a reused component. So we've used card twice. We don't need to fetch it again.
Right. So we're
So there's a few more things to show off here. We'll do a quick refresh. We're going to be in this state here. If someone gets super impatient.
Yeah, I'm very impatient, I know. And I could use like 5 pairs of headphones.
5 pairs of headphones.
Just like you put them all on top of each
5.
other. Yeah, you put them all on top of each other, you get improved audio quality.
I don't think that's how that works.
That's absolutely how it works.
I mean, I'll trust you. 1, 2, 3, 4, 5. Okay, well, how many items do we get in the cart when that finishes loading? We got 5. Pretty cool.
That's very cool.
Another thing to show off here is that this will actually happen before your full app hydration fires off too. So let's say I'm here and I hit refresh. Before that even fires off, you can already trigger those defer blocks. And then the whole app fires, and then the rest of it fires. So it's available to you at the very beginning of the application as well.
And we didn't lose any headphones along the way.
We didn't. You're going to get all 8 of those.
Yes, great audio quality, I'm telling you.
I am not paying for it. So that's the demo. Let's move this back off the screen so we the demo gods were with us today, and now we need that in front. Awesome.
Are the
Okay.
tab switching gods with us?
Yes. So there's still a few more. Why is this not? There we go. Okay, there's still a few more nuances to be aware of. So we have a couple of types of triggers that are passive and a few that are we consider active. An active trigger is one that you actually have to physically interact with, like interaction or viewport, where the user actually has to do something in order for it to fire. The passive ones are essentially immediate and idle, the things that happen like automatically on their own without the user doing anything. And if you're doing full app hydration right now with server-side rendering, these are, because of the top-down behavior, going to behave exactly like you want. You wouldn't actually have any blocks there to fire those idle or immediate triggers because they don't exist yet. So you have to wait for the interaction. But in a partial hydration case, that content's going to be there, and those triggers are going to be on the page, and you aren't necessarily going to want the idle trigger to fire right away if it's nested underneath an active trigger. Yeah. You're going to end up in a performance situation where suddenly you've got a cascade of requests that you weren't expecting. So we treat these slightly different. When you have a parent element that has an active trigger, we don't do anything with the idle or immediate until that interaction actually occurs. However, if you don't have a parent trigger that is active and it's just passive triggers, those are going to fire like normal. The key thing here is that we're focusing on the user interaction as the source of the signal for us to know when we need to actively fetch and hydrate.
So like any good restaurant, the customer is always right.
Always right, yes, always. And then we have this case here where we have those idle and immediate triggers, but there's a button in one of the passive triggers that someone could interact with. So if someone does click on that, essentially, we override any of the rest of the triggers and we forcibly hydrate all the rest of the way up because the user has told us this is a block they want to start interacting with. So regardless of the trigger, that would actually force hydration.
But I'm still a little confused here because I thought defer was an async thing, right? It takes time to fetch from the server, download this content, load it on the application. But events are synchronous, right? As soon as I click the button, that event is gone, right? Or are we like time traveling here or something?
I mean, it's sort of. Like, we just replay it.
What do you mean, like replaying an event? What exactly does that mean?
That's a really good question. So the way that this works is through this library called JS Action. You also would have heard about this yesterday during the keynote. This is a library that was developed by the Wiz team in Google. It was for Wiz initially, and now we're looking at sharing it. The Wiz framework you may have heard also yesterday. It's used by a few small applications like Google Photos, Search, Gmail, Drive.
I think I've used one or two of those.
Maybe one or two.
Yeah.
Maybe one or two. And the way JS Action works is it's essentially a lightweight script, and it gets inlined at the top of your application before anything loads. And that script serves to create event contracts for all of the events that are going to be interacted with on your page. And then it creates essentially what's a global event listener, so that anytime one of those events fired anywhere on the page, it's listening for those events. But it's specifically looking for any element that has something called a JS Action attribute. So that'd be JS Action equals and some information on it. Any element that actually has that stands in for the element that is going to have the event binding on it. And those event clicks or whatever event that it's listening for are then queued up to be replayed a bit later once your app is finished hydrating.
So my click event handlers in the Angular template turn into this JS Action thing, and then at runtime we figure out, oh, you click that button, therefore we'll download this component.
That's exactly how that works. We're really excited about this because this is another wonderful collaboration we have happening between the Wiz and the Angular team. And it's essentially going to be open sourced in the Angular repo very soon. So you'll be able to see these pull requests going up within the next few weeks, and you'll be able to peruse that code for yourself.
So it's kind of like the same way in the keynote, how we had YouTube as a Wiz app was able to use Angular signals. Now we kind of have the opposite thing where Angular applications are able to use this JS Action library from Wiz.
That's exactly right. It's a really awesome collaboration that we have going on.
Very cool.
So that's essentially how we're making the browser smarter and deferring as much content as possible. And now Doug will tell you about how we're improving the server at the same time. Doug?
Sorry, I was hydrating. Yeah, so currently the way that server-side rendering actually works is through something called Common Engine. We essentially have a model that looks sort of like this, where you take in the bootstrap function, your index page, and the route information, and then we render that out into an HTML string. But that's kind of the extent of it. And this mostly works, except that you'll notice that there's no HTTP request or response in this graph. That's something that you, as the application owner, have to manage. And we'll generate for you in the server.ts file, but let's be honest, you haven't looked at that since it was made. You don't know how it works. The challenge with this, Mark agrees. And so the challenge with this is that we as Angular don't have a lot of insight into the actual request and response that you're working with. So what we'd like to see is maybe a change here where we sort of raise Angular to a slightly higher level of abstraction, one which takes in the request from one end and then renders out a response to the other. This seems like a small change, but it actually serves as a very useful primitive that we can build upon for more powerful features.
Did you notice when Doug made that request and Mark made that response?
Exactly. Demoing this live, by the way. So for example, because we have knowledge of the request and response, we can automatically provide that to you, and you can inject this in your component and directly manipulate the request and response as makes sense for you. This can even work on the Vite dev server, which addresses one of our most popular GitHub issues with SSR right now. So you get all of this out of the box automatically. You don't have to worry about it.
Teapot. This is a really good short and stout API.
More of a coffee guy myself, but sure, yeah, we'll go with that. So this higher level abstraction also allows us to integrate better with cloud providers. So now they can just create a small adapter that converts whatever request and response system they're using into the format that Angular expects. This is a much more maintainable integration, and it allows us to evolve our SSR support without breaking those cloud providers every step of the way. So while you might not directly notice this change, you will notice how much more stable your deployments and cloud integrations are. Next, the web speaks a lot of languages, and Angular wants to support all of them.
Yeah, like HTML and JavaScript?
I was thinking like English and Spanish.
Like CSS and JSON.
No, more like Chinese or Italian.
I mean, I guess really any language if you really consider like WebAssembly,
And so we want Angular to support the World Wide Web and all the languages that it covers.
Even C++.
If you really want to. So to do that, we're exploring automatically managing the different localized applications for you. So you don't have to worry about accidentally rendering the wrong locale, and this should mostly make things just work for all your internationalized builds. We're even exploring runtime translations on the server and improving our overall documentation to just provide a better experience all around. But the main takeaway here, kind of as I've said before, is that you don't have to choose between internationalization and server-side rendering. You can just have both. Not only that, but we've been looking into how we can add hydration support to internationalized builds, which we're very excited about.
Yeah, we know a lot of people have been asking for this, and we're really thrilled that it's actually about to actually land. And just wanted to give a huge shout out to Gerald Monaco, whom you may have... You may have seen his talk yesterday, but he is the one who has made hydration for internationalized apps happen. And he's continued to do some amazing work in partnership with the Angular team, since he's on the Chrome Aurora team. And so if you missed that talk, you should consider going back in time and watching it.
I kind of left my time machine at home, but maybe there's a way we could replay that talk?
Well, good news, everyone. Look under your seats, because there's a time. No, there isn't actually a time machine under your seat. But yeah, when it's available, you should replay that talk. So we're heading into our last section here.
Poor dog. He's okay. The dog is okay.
The dog is okay. A little traumatized, but okay. So this section comes with the caveat that these really are truly half-baked ideas, and some even less than that. So please take everything with a huge pinch of salt.
So one idea we're exploring is a new routes config file, specifically one for server-side routing. The idea here is that you can specify routing behavior as specified directly on the server. So for example, here we're defining exactly where routes render. We've got all the dishes pages are going to be rendered on the server. The checkout page is going to be on the client only, because maybe that has some authentication restrictions on it. And then everything else gets pre-rendered. So the idea here is to make it super easy to choose exactly where and when certain routes render, and give you easy ways to opt in and opt out of server-side rendering as appropriate.
So wait, I'm going to have to make another routing file? Don't we already have one of those? Why can't we just use that, Doug?
Yeah, we do have one. And we did consider that, but we found it to be really a bit constraining with the developer ergonomics and the way that code splitting works between the client and the server. Some security challenges with that, they get particularly difficult. So what we kind of realized going through this was that routing on the server is actually a very different problem than routing on the client, and that necessitates sort of a different solution.
But I've got this really complicated routing setup like this, and I really just don't want to have to duplicate that in another file.
Yeah, I get that. I don't want to do that either. That sounds really awful. So the idea here is that while this configuration is a separate file, it applies over your existing configuration in Angular Router. So even though you have that giant list of all these different routes in there, we can still have something that's just this small and simple that just says all the dishes get server rendered and everything else gets pre-rendered. And even if you have 100 or 1,000 routes in your other config, this still works. So the idea here is that you only have to specify the behavior that's actually unique with respect to server-side rendering.
That sounds a lot better.
Yes, that's hopefully much smoother. The next thing we're considering is a getStaticPaths function, which allows you to dynamically generate the data for any pre-rendered routes directly in your application source code. So in this example, we're injecting a dish service and listing all the dishes that are known at build time. This could be fetching from the network, reading from a database, whatever makes sense for you. And then for each dish, we pick out the ID parameter, and that ID parameter gets put into the route path. And that path becomes the thing that Angular renders. And so this becomes a really ergonomic way to be able to generate exactly which routes you want to render at build time directly in your application source code.
Doug, I canceled Dish Network a long time ago. I don't want any dish service. Can I just stream instead?
Streaming is a different talk. That's not this one.
Fair enough.
One more idea is just about what other data we can stick in this configuration that makes sense. So for example, we could consider putting headers to control caching behavior. We could apply redirects immediately without having to bootstrap your application and load your full route configuration. We're also looking at it as status code, so you get real 404 errors for your HTTP responses. All these routing features make SSR much more ergonomic and much more intuitive to use, and so we're excited to explore this more in the future. Another thing is that we're sort of exploring other JavaScript runtimes. Node has been really great for Angular and the web ecosystem. It's not going anywhere, neither is Angular's support for it. But we've seen a lot of interest in the community and in the ecosystem about alternative JavaScript runtimes. And we expect this is going to grow in the future as cloud providers continue to compete for the best performance. And so while you can kind of do some of this with Angular today, it can be a little hacky and a little awkward. So what we'd like to do is get Angular, reduce some of our dependencies on Node, get it a little bit smoother so that if you want to throw Angular on top of another JavaScript runtime, that mostly just works and just kind of works out of the box. And so we're striving for a world where if it can execute JavaScript, it should render Angular.
I'm noticing, Doug, that you put that bun in an oven.
Yeah, that makes sense, obviously.
But our last section was the buns in the oven section. This is like the half-baked ideas section.
It's in the oven. It's still baking. It's a half-baked bun. What do you want? So look, we've thrown a lot of terms at you today, and even defined some of them. The most important takeaway is that Angular isn't just a client-side rendered framework anymore, right? It's evolving, and server-side rendering isn't just supported, it's a core part of the Angular experience. This part's going to continue to grow, and it's one that we think you should consider for your Angular applications.
For those of you that are younger, this is an older meme, but it still checks out.
And so try it out today. Let us know what you think about these ideas and what you'd like to see next. You can use ng-new, ng-add, try it out. We'd love to hear your feedback.
Doug, ng-new -- SSR really seems like a lot to have to type.
How much is it? It's like 12 characters. Come on, Jess.
I know, typing's hard, and it's really easy to do equals SSR.
Okay, I have made that mistake before. I have to confess. So, okay, how about one more half-baked idea then? So what if instead of typing -- SSR, what if we could get all of this SSR goodness by default with just ng-new?
That's a pretty good idea. I like it.
I like it a lot. That's good. Much easier to type. So she's Jess, I'm Doug. That's what's cooking with SSR. Let us know what you all think and give us your own half-baked ideas. Most importantly, over lunch.
Live long and prosper, everyone.